Okay, ladies and gentlemen, let's talk about another exponent topic. Let's talk about powers of powers. What do you do if you have powers of powers? Here's what I mean by powers of powers. Not this. This is what we already talked about. If you have x squared times x cubed, we know what to do with that. But what if you have x squared and you're cubing that? What if you're cubing x squared? Like x squared to the third power. That's what we mean by powers of powers. What do we do with the 2 and the 3 in this situation? Well, let's find out. We already know that there's the good old when in doubt, write it out strategy. So we know that to cube something means to multiply it by itself and then multiply it by itself again. So x squared cubed means x squared times x squared times x squared. And we know that each of those x squareds is x times x. So x squared cubed is really x times x times x times x times x times x. And this is a really simple problem because once we see that, we understand that the answer to this, to simplify this whole thing, is x to the 6th power. Pretty simple. Everybody sees that train of thought pretty clearly, right? Now what I want you to notice is what happened with the exponents. We started with a 2 and a 3, and we ended up with a 6. So what do you have to do with a 2 and a 3 to turn them into a 6? Well, you multiply them together. All right? So the law of exponents that works here is that you could, when in doubt, write it out, but we could just use the law as a shortcut that tells us when you have a power of a power, what are you supposed to do with the two exponents? You multiply them together. So 2 times 3 could have given us the 6 without having to, when in doubt, write it out. Not that there's anything wrong with that. Okay, how about another example? What if you have y to the 8th to the 8th? What do you do with the 2 8ths? Well, we just said that what you do with the 2 8ths is you multiply them together, and therefore this would simply come out to y to the 64th power. And it seems like that's a crazy large exponent, but that's what it is. It's y to the 64th power. And that's it. Except things get a little bit more complicated, so we probably need another example or two. What if you have more than one thing inside the parentheses? What if you have a to the 7th, b to the 4th, and you're taking that whole expression to the 3rd power? Well, in this case, you're just going to do the same thing twice. So what we're going to end up with is a to the 21st power and b to the 12th power, because we're going to do the 3 times the 7 to get the 21, and we're going to do the 3 times the 4 to get the 12. That's actually really easy, isn't it? Oh man, this section is going to be really easy. One last example. What if there's numbers and letters and powers all inside of the parentheses? No problem. Here's what this problem should come out to. It should come out to 32 x to the 15th, y to the 20th. And take a look at that for a second. See if you can figure out where I got those numbers. All right, here's where I got them. I got them because we're doing that whole thing to the power of 5. So I have to take the 2, and I have to do 2 to the 5th power. So I have to do 2 times 2 times 2 times 2 times 2. And then I have to take x cubed to the 5th power, which means I multiply the exponents and get x to the 15th. Then I have to do y to the 4th to the 5th. And so I'm going to take the 4 and multiply it by 5. And that's how I get 32x to the 15th, y to the 20th. If you understood this example, you are golden. All you got to do is a couple more practice problems on your own to see if you understand it, and you're good to go. Try these 2 problems, and I'll check them in class tomorrow. See ya.